Hey everyone, Google DeepMind might have just changed robotics forever. And I'm not exaggerating here. Carolina Parada and her team just unveiled something called Gemini Robotics On-Device. Think of it as a supercharged, slimmed-down version of Gemini 2.0. But here's the kicker. It doesn't rely on the cloud. No Wi-Fi, no internet. Not even a hint of connectivity is required. It runs entirely on the robot itself. Now pause for a second and think about what that actually means. No more delays, no outages, no waiting for a signal to bounce from a server halfway across the globe just to figure out the next step. We're talking real-time thinking and reacting. On the factory floor, inside your home, or even on a robot drifting across deep space. It's like someone finally cut the leash and gave robots their own brain. One that's fast, sharp, always ready, and best of all, independent. And because this model runs completely offline, efficiency becomes everything. DeepMind's engineers had to refine the architecture so it fits inside a dual-arm Aloha rig. But don't let the compact size fool you. It's still powerful enough to handle vision transformers, language encoders, and action decoders. All in a single package. You're not plugging this into some giant server rack either. It runs on embedded GPU boards, the kind you'd actually find inside mobile manipulators. That tight integration means the robot can react within tens of milliseconds instead of hundreds. So let's say a sensor picks up a slight shift in the way an object is positioned. With this kind of speed, the robot adjusts before the object drifts out of place. It's that fast. And yeah, DeepMind backed this up with numbers. They ran side-by-side benchmarks, pitting the on-device version against their flagship A hybrid model, and even against the previous best local-only systems. What happened? The on-device model clung right to the hybrid's curve across tests that measured visual understanding, behavioral generalization, even semantic reasoning. And when you throw in unpredictable conditions, like never-before-seen objects or weird lighting, the on-device version holds up shockingly well. Even for tasks involving complex multi-step instructions with natural language, it's closing the gap fast. Honestly, what blew me away was the demo reel. The robot unzipped soft lunchboxes. It folded shirts with actual creases. It poured salad dressing into narrow containers without splashing. It even slid a card out of a deck with these subtle, precise motions. Here's the kicker. It did all of that after seeing only 50 to 100 examples. That's it. That number matters because gathering data is expensive. Whether you're training in a simulation like MuJoCo or manually demonstrating actions on a physical robot, it adds up fast. Cutting that demo count down to double digits makes this technology way more accessible to researchers and developers who don't have warehouses of teleop footage just sitting around. Now, remember when self-driving cars still felt like sci-fi? Back in 2019, people were skeptical. Fast forward to today, over 400,000 Teslas are driving themselves every single day. Meanwhile, AI adoption in businesses jumped 270% in just 3 years. Companies that embraced it are now 15% more productive than their competitors. McKinsey estimates AI will add $13 trillion to the global economy by 2030. But it'll also force 375 million people to shift careers entirely. That's not a maybe. That's already happening. Okay, back to Gemini. So after training this on-device model on Google's Aloha platform, DeepMind decided to test its flexibility. They took the same trained model, same weights, and ported it over to completely different robots. One was the Franka FR3 ARM workstation, and the other, the Aptronix Apollo humanoid. No retraining from scratch, just a short adaptation pass. And it worked. On Franka, It executed belt drive assemblies, aligned pulleys, tensioned belts, and even folded long summer dresses, delicately. Meanwhile, the Apollo humanoid, which is much taller with completely different limb geometry, followed spoken instructions, manipulated unfamiliar household items, and tucked a Rubik's Cube into a pouch like it had practiced it all week. What that tells us is huge. We're inching closer to something called embodiment-agnostic skill libraries. Basically, you train the skill once, and it transfers almost anywhere. If you're a developer, this gets even better. You can sign up for the Gemini Robotics SDK right now. It ships with live robot interface code, full Mujoko simulation scenes, and tools to fine-tune your own tasks, even offline. You can record demos, fine-tune locally, and push new behaviors straight onto your robot's flash storage. And yeah, this is Google's first VLA where local fine-tuning is fully supported. That's game-changing. Now, don't expect it to be fully open source just yet. Access is going through a trusted tester program because, let's be honest, safety has to come first. And DeepMind's not taking shortcuts there. They've built in semantic filters to catch unsafe instructions. Like if someone told a robot to hand them a knife, blade first. There's also a low-level safety controller, constantly checking for torque limits, collision zones, and velocity caps. They even developed a semantic safety benchmark to throw every awkward or confusing edge case at the model, just to see if it breaks. Nothing gets deployed until DeepMind's Responsibility and Safety Council gives the green light. Because yeah, when you've got 200 pounds of moving metal swinging near a human coworker, you want those safety nets. Now look, the hybrid model still wins when it comes to solving really complex tasks, like manipulating objects based on nuanced multimodal instructions. But even Carolina Parada admitted they were surprised by how powerful the on-device model already is. It's a starter, she said. But in rough environments, where Wi-Fi is spotty or data privacy is non-negotiable, this thing is already close to production grade. And here's what it really unlocks: logistics hubs who's juggling changing inventory every week. Hospitals needing offline robots that are completely self-contained. Even planetary rovers crawling over lunar dust, where one ping to Earth takes way too long. On-device is more than just a stripped-down Gemini. It's a new way of thinking. Robots that work in real time, think on their own, and learn fast. So if you're working in robotics, this is your signal. Go sign up for the SDK, get in that tester queue, and start queuing up your own demos. The future isn't in the cloud anymore. It's sitting right inside the robot. I'll see you in the next one.